Hi everyone. So let's start the fourth unit, push down automata. So before start, let's go with the background issues. So Chomsky hierarchy, we already discussed it in the first classes of the formal language and automata theory. So Chomsky hierarchy is used to classify the grammar in four different types, that is a type 3, 2, 1, 0. And so we already completed type 3. So that is a regular grammar, and the regular grammar is accepted by the finite automata, which means so for the grammar the mission format is finite automata. In the same way, type 2 grammar is also called as a context free grammar, and the mission format of the context free grammar is nothing but push down automata. Okay, so now you understand where we can have a push down automata for the context free grammar. So the mission format is nothing but a push down automata. So first have to understand why we need a push down automata, then we go for the what is push down automata. Okay, so let's consider an example and construct a mission. So consider a mission for the language a power m b power n, where m n greater than or equal to 1 means 1 to many. Okay, so in here we construct a FA here. So it consisting some states, initial state and final state, and state transmissions from Q0 to Q1A, and Q1 to Q1A, and Q1 to Q2B, Q2 to Q2B. Okay, and if you observe the language strings a power m b power n, there is no relation between the m and n. Okay, we can have any number of a's as well as we can have any number of b's. Okay, so here we can directly construct the mission by using the FA. Okay, so let's see another example. Consider a mission L2 a power n b power n, so where n greater than or equal to 1. Okay, so can you design this with the FA? So it is not possible. Why? I will tell you. So first understand the language strings, a power n b power n. If you observe the things, how many number of a's are present in the string, the same number of b's has to be constructed. Okay, how we construct b's, it is actually depending on the number of a's. That means there is a relationship between the number of a's and the number of b's generated by the language constructed by the mission. Okay, so as many a's, that many b's only that many b's we have to construct. So these are the strings example. So for this language we cannot design FA. So why? Because FA has a limited memory. So in this language, so for constructing B, we have to remember how many A's already constructed. That means it requires a memory. We have to remember, and that can be in the stored area. Okay, so we need one more powerful mission than FA, that is nothing but a PDA. Okay, so understand from the example what you understand is, so for constructing this kind of mission, so the system has to remember something. Okay, that means it requires storage memory. So FA is a limited memory, that is not enough for this kind of languages. For this we need another mission, that is nothing but a PDA. Okay, so let's go with some informal definitions of a PDA. So PDA is the same as a finite automata. Finite automata with extra memory is called as a push down automata. How a regular language is meant for finite automata, context free language is also meant for push down automata. And when it comes to the second definition, we can implement the regular language using the FA or a DFA. In the same way we can implement the CFG using the push down automata. So third definition, so PD is an NFA epsilon with a stack. PDA is a NFA epsilon with a stack. So that means simply NFA epsilon is nothing but FA only. With stack it is called as a PDA. Okay. So another informal definition is nothing but a push down automata is simply finite state mission or finite mission, finite automata mission as well as the stack. The combination of these two is simply nothing but push down automata. Okay, so you hope you understand the informal definitions. Simply, what is a push down automata? Push down automata is a mission format of context free grammar, and it is same as a finite automata with extra thing is stack. Here stack is meant for storage. Okay, so when it comes to the basic structure of a PDA, so here the mechanical representation of a PDA. Here we have a three components: input tape, control unit, and stack with the infinite size. So this is the mechanical format of a push down automata. Here it is input tape, that is a finite control, and a stack, and finally so whether the accepted or not we have as a result. Okay, from the input tape the finite control takes input symbols, and from the stack also it takes some data, and it will, I mean, that it pops the data as well as it push the data into the stack by the finite control unit. Okay, so this is a mechanical representation of a push down automata PDA. So you know about a stack, right? So in the data structure you have a stack. Stack is a storage, and a set of operations are possible, that is a push and pop operations. Push means inserting the data into the stack, and pop means retrieving the data from the stack, and it follows a it follows a rule called last in first out. Means last in inserted data can be first out, can be out first. Okay, so let's go with the formal definition of PDA. So PDA, you know already, mission format consisting a set of tuples. In FA also we discussed about 5 tuples and all. So here 7 tuples exist in the PDA formal definition, mathematical notation. So that is a Q, sigma, tau, delta, q naught, z, f. So we'll see one by one. So q is nothing but a set of states, and it is should not be null, and sigma is nothing but input alphabet terminals, and tau is nothing but a finite set of symbols called stack alphabet. A set of alphabets of the stack is present in the tau, and delta is nothing but transition function. So we'll discuss transition function in depth later. So q is a states, sigma alphabet set, union epsilon, it may include epsilon or not, sometimes it may, sometimes it may not be. So next tau means stack alphabet. So when we combine all this, we transform it in new state, that is also part of a set of states, and we have a tau star is nothing but a new symbol into the stack. Okay, we can push the new symbol of as a result to the stack. And the next one, q naught, is the initial state. It is also part of a set of states, and f is a final state, and it is also part of a set of states. Remember, same as a FA, here also we have a single initial state as well as the more than one final state, and one more notation in the tuple in the definition, z is nothing but initial push down symbol. So stack is actually an empty, and we can push z as a initial symbol into the stack. So next, here we have a note here. Instead of z, we can also use some I, dollar, z naught symbols as the initial push down symbol. Okay, so some terminologies can be used here. They are instantaneous description. The ID of a PDA is represented by a triplet. That means a combination of three elements, that is Q, W, S notations. So Q is nothing but a state, W is nothing but unconsumed input, that is a part of input string, and S is nothing but a stack content. So Q is nothing but a current state, W is nothing but a symbol from the input, S is nothing but a symbol from the stack. So it is a ID is nothing but a triplet, And the next one, turnstile notation. Turnstile notation is nothing but used to connecting pairs of IDs. Already we know what is an ID. ID is a triplet which includes current state, state, and the next one input symbol, and after that stack symbol. Okay. For representing the transitions from one state to another state, this Tn can be used. The notation used, this one here, this kind of a notation used for transitions. So this is a transition. Here we include a Tn. So this is ID and this is another ID. We can connect these two IDs with the Tn notation. So P is a state here, B is a input symbol, T is the top of the stack, and Q is a state here, W is a input symbol, and next one alpha is a alpha is also a element to the stack. Okay. And to represent more than one move transition, so we can use Tn star here. Okay. This is about PDA and definitions. This is about PDA definitions, informal definitions, and components of the PDA, and formal definition of PDA, and terminologies related to PDA. Okay.